Look at this landscape. A massive, endless mountain of rust and decay.
Underneath the baking sun, millions of discarded air conditioning compressors sit in silence.
Once, these heavy, ironclad machines were the beating hearts of our modern comfort.
They hummed away in the background of our lives.
To the untrained eye, this looks like the end of the line, a tragic graveyard of electronic waste.
Slowly being consumed by rust, dust, and time. It looks like a massive environmental problem.
But in this mega factory, the word waste simply does not exist. What you are looking at right now is within these thick, heavy steel shells lies one of the most versatile, valuable, and infinitely recyclable materials on the planet.
Today, we are going to witness an absolute miracle of modern engineering.
We are going to follow the complete, mesmerizing, and sometimes violent journey of how
The journey of 1,000,000 miles begins with a single mechanical grab. A massive, heavy-duty crane drops its payload. Dirt, rust, and debris rain down as the machines are dropped onto a heavy-duty conveyor belt.
The compressors are moving steadily toward a dark, looming structure. This is the primary shredder, the jaws of the mega factory.
As the machines drop into the shredder, the sound is deafening. Inside, massive twin-shaft steel...
These aren't just cutting blades. They operate on pure, unadulterated torque. They apply thousands of tons of crushing pressure,
effortlessly chewing through the quarter-inch thick steel casings, as if they were made of thin cardboard. Bright orange sparks explode through the air.
The shredder doesn't just cut, it tears, rips, and shatters the machines into unrecognizable, jagged fragments. But as the machines are broken open, they begin to bleed. Now it is a toxic hazard. As the metal is ripped apart, the thick black oil spills out. It is immediately drained through special industrial grates,
Carefully pumped into sealed vats and sent away for safe chemical treatment and disposal. Carefully pumped into sealed vats and sent away for safe chemical treatment and disposal. Once the shredder has done its brutal work, the tough steel casing is gone, exposing the delicate, valuable innards of the compressor. Once the shredder has done its brutal work, the tough steel casing is gone, exposing the delicate, valuable innards of the compressor.
There are jagged shards of heavy iron casing, bright orange copper wiring, bits of plastic, and our grand prize, the lightweight aluminum. Before we can melt anything, we have to isolate the aluminum. This is where the brute force of the shredder is replaced by the silent magic of physics. First, we need to get rid of the iron and steel, which makes up the bulk of the weight. To do this, the conveyor passes underneath a massive electromagnet. Because iron and steel are highly magnetic, they violently snap upward, flying through the air and sticking to the magnet above, completely separated from the mix.
But we still have a problem. What remains on the belt is a mix of copper, plastic, and aluminum. None of these are magnetic.
You cannot pick them up with a standard magnet. So how do you separate thousands of tiny silver aluminum shards from copper wiring at industrial speeds? The answer is a stroke of absolute engineering genius called the Eddy Current Separator. As the mixed metals reach the end of the conveyor, they pass over a rapidly rotating magnetic rotor inside the belt. This spinning magnet doesn't attract metal. Instead, it induces a powerful electrical charge and eddy current inside the highly conductive aluminum pieces.
In a fraction of a second, the magnetic field literally repels the aluminum. If you watch closely, it looks like pure magic.
The silver aluminum shards suddenly jump off the belt, launching themselves through the air into a distant, dedicated collection bin. While the heavier copper and plastic simply drop straight down off the edge. Through the sheer brilliance of the Eddy Current Separator, we now have... But in this loose, fragmented form, the aluminum is incredibly difficult to transport. And worse, it is dangerous to melt. If you throw millions of tiny, loose pieces of metal directly into a massive fire, much of it will simply burn away into the atmosphere before it ever melts. The metal needs to be dense. It needs to be heavy. The loose aluminum shards are funneled into the chamber of a massive hydraulic baling press.
This machine is a modern marvel of fluid dynamics. Hydraulic rams, pushing with thousands of pounds of pressure.
You can hear the screeching and grinding of the metal as the air is squeezed out of the pile. The jagged pieces are violently crushed and locked together. When the press opens, what was once a loose pile of scrap is now a highly dense, rock-solid, shiny silver cube weighing hundreds of pounds. In modern megafactories, human hands rarely touch the metal at this stage. We rely on an army of automated robotic arms.
Capable of lifting tons with pinpoint precision, these yellow steel giants gracefully grab the heavy aluminum bales. They rotate, align, and place the blocks onto a heat-resistant conveyor belt. They are moving the metal toward the beating, fiery heart of the factory. The smelter. This is where the magic truly happens. As the aluminum bales approach, as the giant, heavy steel doors of the massive industrial furnace slowly slide open.
Instantly, the factory floor is bathed in a blinding, glowing orange light. The heat is so intense that the air around the furnace visibly warps and ripples. Inside this crucible, the temperature is pushed well beyond 660 degrees Celsius, the exact melting point of aluminum. The heavy, dense bales of crushed scrap are thrust directly into the roaring flames. Inside the belly of the furnace, a profound transformation begins. The solid metal begins to sweat, then soften. And finally, it surrenders entirely to the heat. The rigid, blocky cubes collapse and melt, dissolving into a deep, bubbling pool of glowing, liquid orange fire. Despite our best efforts, during the sorting process, some impurities always sneak into the furnace. Traces of paint, thin layers of plastic, or microscopic bits of dirt. But the furnace is the ultimate purifier. In this intense heat, these non-metallic impurities
are incinerated instantly. Because they are lighter than liquid aluminum, the burnt remains float to the very top
of the molten pool, forming a dark, crusty layer of ash and rock known as slag or dross. A massive mechanical arm, equipped with a heavy skimming blade, reaches into the molten lake. With careful precision, it drags across the surface, skimming the dark, useless slag off the top. Look at what is left behind. It is a mesmerizing, perfectly smooth. The metal has been entirely stripped of its past. The rusty, oil-stained compressor is gone. The aluminum has returned to its raw, elemental state.
Now, it is time for rebirth. The massive furnace, holding tons of liquid fire. A glowing, brilliant river of molten aluminum pours out of the spout like a waterfall.
Sparks dance in the dark factory air as the liquid metal is carefully directed through a series of ceramic troughs.
It flows seamlessly into long, perfectly shaped rectangular steel casting molds. But liquid fire is no use to builders. It must be turned back to stone. As the long molds fill to the brim, the quenching process begins.
To lock the aluminum's internal crystalline structure and give it maximum strength, it must be cooled rapidly. High-pressure jets of freezing cold water are sprayed aggressively across the bottom and sides of the red-hot steel molds. The violent collision between the intense heat of the metal and the cold water creates that completely swallow the machinery. For a moment, the metal is hidden in the fog. But as the vapor slowly clears, the glowing orange color has faded away. In its place rests a beautiful, brilliant, solid block. These giant, solid blocks are known as aluminum ingots. They are incredibly pure, but their journey is not quite over. To be useful in manufacturing, they need to be perfectly shaped. The massive ingots are moved down the line where they meet a terrifying piece of machinery. A high-speed industrial circular saw. Equipped with diamond-tipped blades, this saw spins at incredible speeds, effortlessly slicing through the thick ends to remove any rough, uneven edges left over from the casting process. Silver metal shavings fly through the air like snow as the block is trimmed to... Finally, the aluminum undergoes the extrusion process. The ingots are heated just slightly, not enough to melt them,
but just enough to make the metal soft and malleable. Massive hydraulic rams then push the softened aluminum through heavy steel dies
that have specific shapes cut into them. Think of it like squeezing a tube of toothpaste. The immense pressure forces the metal through the tiny opening, and it emerges on the other side as endlessly long, perfectly smooth, continuous silver bars. They glide down.
In the packaging wing, a symphony of automation takes over. Dozens of sleek, robotic arms work in perfect harmony.
They swoop down, gently pick up the newly formed aluminum bars, and stack them into massive, mathematically perfect geometric rows. The contrast is staggering. Just a few hours ago, this metal was a chaotic, rusted dirt.
Loaded onto heavy flatbed trucks, these gleaming aluminum bars leave the mega factory to build the future. This metal, which once cooled your living room, will now find a new purpose. It will become the sleek frame of an electric...
It might even become the wings of a commercial airliner, flying 30,000 feet in the air. Aluminum is a miracle element.
From waste to wonder. Thank you for watching this incredible journey. Hit that like button, leave a comment below, and don't forget to subscribe. Join us next time.